Alright, yeah, welcome to this lesson, and in this video we have been asked to examine the function e to the power of 1 over x and to check if it is continuous at x equals 0. So what is from our previous lesson, we have three conditions to this, and the first one says that f of a must be defined at x equals a, and this is equals a. So it says f of a must be defined, must be defined. Now, define means the function must exist at x equals 0 or a equals 0. So let's do that. So we have f of a equals f of 0 as we have here, and that equals e to the power of 1 all over 0. You see, now at this 1 over 0 here, this function is not defined. So we can simply say here that at 1 over 0, comma, f of x is not defined. It's not defined. So f of a, so the first condition already fails. Number 2 says that the limit at x approaches a from the left of f of x, this limit must equal the limit as x approaches a from the right of f of x. Now let's check both sides. The limit as x approaches, what's our a? 0 from the left of f of x is equal to e to the power of 1 dividing, let us pick a number to the left of 0, a very small number, very close to 0, but to the left of 0. So we can pick negative 0.00001, and we'll be seeing that as we pick a number very close to 0, to the left of 0, this number will be getting bigger. So this number will not be stable. That is, this number will not settle to a point. It will always increase as you pick a number very close to the left of 0. So because we have that, this number at the top here, we always approach negative infinity. That is infinitely small number, and by the power law we have this to be 1 dividing e to the infinity, and we know that this is a very large number. This is a very large number by this rule, and if you divide a small number by a very large number, this will always approach 0. You can give an example by saying 1 dividing 1 million, it will always approach 0. 1 dividing 1 billion, we always approach 0. So that is the left hand limit. So the right hand limit says that the limit as x approaches 0 from the right of f of x is equal to e to the power of 1 dividing 0.00001, and this should also approach infinity, and a very large number to a very large number will give us a very large number. You can see that this limit as x approaches a from the left of f of x does not match the limit as x approaches a from the right of f of x. Second condition also fails. So the third one says that the limit as x approaches a from both sides of f of x must equal the first condition, f of a. But this one also fails because the first one is undefined and the limit does not exist. So we can say this one fails too. So this function f of x equals e to the power of x is not continuous at x equals 0. Thank you, and see you in the next lesson.